Hey Vadims, you promised me to tell about memory something. Computation.
In memory computing?
In memory computing, yes.
Okay, yeah.
So maybe now it's the time.
Okay. So you want me to kind of elaborate on this topic,
right? With your shiny two teeth.
Yeah. Okay. Okay, so let me introduce you a really exciting topic which actually revolutionized it, I would say, the computing. And yeah, as you said, it's called in-memory computing. Actually, have you ever wondered how some applications really they do their calculations and data manipulations like at mind-blowing speeds? Did you ever think about it? How it's done?
Quantum computing?
Almost, yeah, but more possible thing, less impossible. Well, actually, the whole secret lays in bringing the whole database in memory.
Ooh, on the last conference I've heard about it.
Yes,
In memory database.
yes, exactly. But it was not in memory database, it's in memory computations. So, okay, to explain you this topic, I will give you some usages of this technology, some advantages, some disadvantages, like drawbacks, and yeah, of course, real life examples. Okay?
Sure.
So, as for usage, this in memory computing actually finds its usage in very different industries, driving some crazy results. And as for usages, I can give you like three things understandable for everyone. Okay, so this would be real-time data analytics, some super high performance applications, and I would say something which is called IoT, Internet of Things. And like briefly example of each of them would be. So for real-time data analytics, basically having the database in memory, like full database in memory, allows businesses to analyze really huge amounts of like different data instantaneously. It's everywhere from e-commerce tracking customer behavior to, let's say, financial institutions monitoring transactions. So this real-time analytics actually allows them to make very profound decisions, data-powered decisions. Data-driven design,
Yes.
DDD.
Yeah, it's another DDD.
Yes, it's not this
When
one.
your decisions are made based on data.
Yeah, you can say that. And all the decisions, exactly because of the database being in memory for such real-time applications, it can be done in memory, and yeah, that's what you call informed decisions. For high performance applications, I can name something which requires fast response times and intense calculations. Like gaming, virtual reality, augmented reality. It can benefit a lot from in-memory computing, and it enhances overall user experience by eliminating all the lags and response times, minimizing them. And for IoT, actually, all these in-memory applications are really crucial. Yeah, because they basically deal with huge amount of data from very different and a lot of connected devices. And processing and actually reacting to this data in real time at the end enables efficient monitoring and controlling of the all this IoT system for all these IoT devices. Okay, so let me actually tell you advantages of all this in-memory computing. Okay, so as you asked it, I can give you four like pieces of what are the advantages of this. So first of all, it would be blazing speed. Second is a pure scalability. The third is, as a consequence, real-time decision making. And of course, I cannot skip a very simplified data architecture. By actually sitting in RAM, the data is accessible at microseconds, making it, all these calculations like super pleasantly fast, which at the end increases user experience for all. And also it increases productivity. For scalability, all this huge masses of data can reside in one place. That means such in-memory computing things can handle a huge massive of data, and it offers a perfect scalability for businesses to grow their businesses actually and increase all these calculations without losing performance, without opposing this, which enables businesses actually to react swiftly to changing circumstances. And actually with this in-memory computing, the need for indexing and like excess data reads from the disk is reduced. So at the end, this actually simplifies architecture also, which also simplifies maintenance. And despite all of these advantages which I mentioned, actually in-memory computing comes with some drawbacks, I would say. At the cost, the price. Storing huge databases in memory actually requires a lot of RAM, which is not cheap. Pretty expensive if you compare to, the usual disk drives. So the second drawback, I would say, it's data volatility. So in-memory data is actually pretty volatile, and if you have a data corrupted or power loss, it's a kill switch. Basically, you lose everything till you back up regularly on the disk. The third drawback is actually it's a limitation. It's memory limitation. So all the data which you can calculate in memory is limited by amount of memory you have. So if you don't have enough of RAM for your all this data set and calculations, basically, poof, you cannot work with it. So yeah, it's pretty limited by the amount of which of what you have.
It's everything cool and impressive, but maybe you could explain it with some examples for an average usage, or for your grandma. How would you explain what you really do at work for your grandmother?
Okay, I will not explain to your mother in memory or my grandma in memory computing, but okay, let's say some real life examples of things which we interact with every day, like we're sitting on the laptop, for example, not creating this stuff, but actually using some stuff, like examples of this, okay?
Would be good for the start.
Okay, stock trading. Yeah, trading companies that actually rely on real-time data analytics on this in-memory computing stuff to do something which is called high-frequency trading, which allows them to capitalize basically on market changes in microseconds. Okay, then what are you doing now? It's online gaming. So basically, in-memory computing allows multiplayers. So people can play multiplayer games online, not having a lag, thanks to this in-memory computing. So a lot of data actually is being analyzed on the fly in microseconds on this inside level, and it allows a lot of people actually interact inside of online games.
Especially with high resolution. It's very heavy.
Yeah, but high resolution is basically also okay. Video computing also, yes.
Because it needs even like a lot of elements, even more elements if it's higher resolution.
You can call it like this, yeah. But there's a theory of these triangles and hexagons and polygons, and actually, I can actually tell you during the next dinner, let's say, about this. But let me just finish about in-memory computing, okay? I will not be able to sleep if I will not tell you now everything what I know. Okay.
Okay, I will wait.
Okay, just one more example, okay? Just the last example I will give you, and that's all for today. So, let's say the transportation apps, Uber, Bolt, and so on, they actually use a lot of this in-memory computing things for real-time computations to decide the road and all of this interactions, traffic data, and so on. So, yeah, they use a lot of this. That's the third example. The last one, I promise.
So probably the smart city, the infrastructure, if we will start using it really in real time, like with self-driving cars, calculating the road, with human movements and the light changing.
Yeah, so it's all to make it possible. We need really fast calculations in real time and all this in memory computing.
And good internet connection.
Yes, and good internet connections. It's actually the thing what allows us to benefit from all of this. Okay, so in short, just to finish, in-memory computing actually changed the way for businesses and applications to work with real-time data, making all these computations and calculations really lightning fast. And even if it's kind of fast and cool thing, anyway, you have to consider the cost and data volatility in case of something happens. And yeah, as you mentioned, as you notice it, all this in-memory computing actually it continues to shape the real life, and actually it will continue to shape the future. And it actually will allow us to, to harness all of this computing power like we never seen before.
I know with the generative AI, it goes in direction that the videos will be created for you in real time, like with your preferences, what you like, because there are already experiments with animation movies.
I saw
think.
cartoon,
Yeah,
how it's
it's
called,
like
the South Park.
yeah,
You know the South Park?
yeah,
They're creating now a cartoon series, the South Park in real time, and it's generated. They have dialects and so on. Actually, also that's a good. I will not do that at home anymore. Sorry. Actually, that's also a good topic. I can tell you about the AI, all the generative things, and even the ChatGPT, how it works, how it predicts the words, how it generates things, text, and yeah, let's do that. The next subject, or one of the next subjects for our all these dinner talks. Okay. So for now, let's just finish with the in-memory computing.
and go sleep.
Yes. So did you get what is it? What is it used for? Like why it's pluses and minuses and so on, right?
Yes, you
Perfect.
explained very well.
Good. And I see you secretly are filming. So if you'll put it somewhere in the channel, please like, subscribe, share with your friends. And if you need more deep technical talks, or even if you need help implementing this, you can always write me, call me, or put a calendar invite and we can discuss how can I help you. Okay?
Thank you, Vadims.
Perfect.
Good night.
Good night.